The video presents approximately 10 coding questions designed to help viewers prepare effectively for the TCS Ignite exam. Engaging with these questions can significantly enhance problem-solving skills. A critical element discussed is the scenario-based nature of the exam questions, demanding concise and efficient coding solutions. This method assists candidates in addressing real exam challenges with greater effectiveness. The tutorial incorporates examples such as reversing a string and identifying prime numbers, showcasing fundamental coding techniques. These examples elucidate essential concepts vital for coding interviews. The function treats numbers less than 2 as non-prime, while 2 is explicitly defined as a prime number. This establishes clear base conditions for the prime checking mechanism. An additional function aims to find two prime numbers that sum to a specified number, exemplifying the practical application of prime checking in problem solving. The code incorporates a mechanism to address scenarios where no two primes can sum to the input number, ensuring users receive appropriate feedback when no solution exists. The video illustrates how to determine if a number can be expressed as the sum of two prime numbers, utilizing examples like 27. This effectively demonstrates the algorithm's logic across various inputs. A comprehensive explanation of calculating the factorial of a number is provided, showcasing the recursive nature of the function with examples, such as the factorial of 5. The base condition for recursion is underscored. The concept of palindromes within strings is introduced, detailing the method to check if a string reads identically forwards and backwards. This adds an intriguing layer of complexity to string manipulation. The approach for calculating the sum of even and odd numbers in an array is also examined. This process involves iterating through the array and assessing each number's parity. An example array illustrates the computation of even and odd sums, featuring specific numbers and the resultant totals to clarify the calculation process. The video elaborates on the implementation logic for summing even and odd numbers, demonstrating how to initialize counters and employ conditional statements effectively. The detailed process of iterating through an array and checking each element for evenness or oddness is emphasized in the video. This method aids in appropriately updating the sums. Finding the maximum element in an array is demonstrated via a loop that compares each number with the current maximum value. This ensures accurate identification of the largest number. The concept of binary search is introduced, explaining how the search space diminishes by eliminating half of the array based on the midpoint. This approach enhances search efficiency. The algorithm initializes pointers for the start and end of the list, employing a while loop to maintain a valid search range. This guarantees efficient searching by avoiding unnecessary iterations. The mid-value is calculated to determine the current search index, aiding in the decision of whether to search in the left or right half of the array. This strategy considerably reduces the search space. If the target value remains unfound, the algorithm returns a specific indicator, such as -1, to clearly signify this. This provides users with a clear understanding of the search outcome. The Fibonacci sequence is presented as a series where each number equals the sum of the two preceding ones, beginning from 0 and 1. This mathematical concept is widely utilized in programming and algorithms. A function is implemented to generate Fibonacci numbers up to a designated limit, demonstrating practical coding techniques in Python. This involves utilizing loops and conditional statements to control series generation. Lastly, the video addresses the method of calculating the sum of digits in a number by converting it to a string for seamless iteration. This approach simplifies the process of summing individual digits through a loop.